So today we'll be working on sampling distribution. This should not be very long, but you need to understand the fundamental concept behind the sampling distribution. We are going to look at the theoretical part, and also we are going to explore some examples based on the theory that is laid out here. And with this, we'll be completing our chapter 6. So the sampling distribution is nothing much different from what we have studied in last class. What we'll have is, in sampling distribution, we'll have a population. You may also want to add all these in your note catcher. So you'll have a population. Population can be of any type. When I say any type, it may be normal or it may not be normal. So we'll have a population first. And from the population, we'll draw the samples. We'll draw many samples. Say, for example, S1 is the first sample. S2 is the second sample. S3 is the third sample, and so on. We may go up to the nth sample. So we'll draw different samples from the population. Now, once we draw the sample from the population, the size of the sample may be different, but here, when you draw the samples from a single population, the size of the sample is a fixed. Maybe you are drawing all samples of size 10, or all sample of size 20, all sample of size 30, all samples of size 50, and so on. So size of all the samples that you are drawing from this population must be same. Say, for example, that is n. N is the size of the sample. Now, once we have the samples drawn here, we can calculate the statistic from the sample. Say, for example, you may calculate a mean or you may calculate the proportion. So you may calculate the mean, like the mean of the first one, x1 bar, mean of the second, x2 bar, mean of the third one, x3 bar, and mean of the nth sample, xn bar. You may calculate the mean, or you may calculate the proportion like in the previous class, or you may calculate the proportion P1 hat or P2 hat or P3 hat, and for the last one, Pn hat. So you have the population. You are drawing many samples of a constant size n, and then you are calculating the statistic like mean or proportion. And then what you're going to do is you are going to consider these statistic as your random variable, the mean as the random variable or the proportion as the random variable, and you are going to draw the distribution. So along the x-axis, when you draw the distribution, you may have the mean or you may have the proportion, and you will draw the distribution. So this distribution which is created here, it is called the sampling distribution. If along the x-axis your random variable is a mean, then we say that it is the sampling distribution of sample means. And if along the x-axis you have the proportion, then we say that it is the sampling distribution of proportions. We have more to explore on the sampling distribution. So first we are going to talk about the sampling distribution of sample means. So meaning of that is you have the population and your samples are, or for the samples you are calculating the mean. So a sampling distribution of sample mean is a distribution using mean computed from all possible random samples of a specific size from the population. So here you can see everything is clearly defined. So a sampling distribution of mean is a sampling distribution of means computed from all possible random samples. So you have the population, one more time, you have the population. From here, you are drawing all possible samples, S1, S2, S3, all the way up to Sn. These are your samples. And from each sample, you are calculating the mean. But remember one thing, these samples are of specific size. Okay, specific size is taken from the population and then the mean is calculated. For example, the mean of first one is x1 bar, x2 bar, x3 bar. For the last one, xn bar. So along the x-axis, you have the mean and you draw the distribution. So this is the sampling distribution of sample means. There are few properties of this that you need to know. The mean of the sample means will be same as the population mean. So if you want to find the mean of this one, if you want to find the mean, make sure you write this down. So in the middle, you know that there will be the mean. This mean of the sample means is written like this, mean of the sample mean. So mu subs x bar, okay, mu sub x bar. So this is equal to the population mean. This is equal to the mean of the population. That is the meaning of that. The mean of the sample mean will be same as the population mean. So that is one formula that we need to know. So you can write that down, mean with the uh, subscript x bar down there. Make sure you, okay, something is not working. Give me a second here. So yes, the mean of the sample means is equal to the population mean. This is the formula that you need to write. That's very important formula, because once we have the distribution, we must know the mean and the standard deviation, then only we'll be able to find the probabilities. That's why we need this. The standard deviation, now after the mean, we need the standard deviation. We got that. Now the standard deviation of the sample mean will be smaller than the standard deviation of the population. So if the standard deviation here for the population, if the standard deviation is sigma, the standard deviation for the sampling distribution will be smaller. Okay, standard deviation of the smaller than the standard deviation of the population, and will be equal to the population standard deviation divided by the square root of the sample size. Meaning of that is this: if you want to write the formula for the standard deviation, we write like that. Okay, standard deviation sigma, and you write sub x bar, because this is the standard deviation of the sampling distribution of sample means, which is equal to the population standard deviation, because it will be equal to the population standard deviation divided by the square root of the sample size, the square root of the sample size n. So that is the formula. Okay, the standard deviation of the sampling distribution of sample means is equal to population standard deviation divided by square root of n. Remember one thing, sometimes this standard deviation, it is also called the standard error of the mean. Sometimes we use that term. So you need to know that this is also called the standard error. We write SE, the standard error of the mean. Standard error of the mean. Add that in your note catcher. So I laid out those formulas over here. Mean of the sampling distribution is equal to population mean. Standard deviation is equal to population standard deviation divided by square root of n. And the standard deviation of sample mean is also known as standard error of the mean. Example, children between the age of 3 and 7 watch an average of 27 hours of television per week. So that is the average number of hours they watch television every week. Assume that the variable is normally distributed, meaning of that is the population is normally distributed, and the standard deviation is 4 hours. That is the information about the population. So let's write those things down. So here, what they have given is mean, which is mu for the population, is equal to 27 hours. Standard deviation is equal to 4 hours. Okay. mean equal to 27, standard deviation equal to 4. Your sample size, now you can see here, if 25 children between the age of 3 and 7 are randomly selected, we have to find the probability that mean number of hours they watch television will be greater than 25 hours. So if 25 children are selected at random, this is your n equal to 25, and population is normally distributed. Assume that the variable is normally distributed and population is normal. That is given to you. This is the information that is given to you. They have given the mean, they have given the standard deviation, you have the sample size, and you know that the population is normally distributed. If you recall from previous class, where we studied about the central limit theorem, when the population is normally distributed, the sampling distribution is always normal. That's what we know from the central limit theorem from previous class. So we are going to take that here. Let's add that from, write this down, from central limit theorem, the sampling distribution, the sampling distribution of sample means is normal. That is what we know from central limit theorem. Meaning of that is, if along this x-axis you have, the sample means, the distribution is normal. Now, if the distribution is normal, what we need is, we need the mean and we need the standard deviation for this one. Now, the mean of the sampling distribution of sample means, we write mean like this, mu sub x bar is equal to the population mean. And the population mean is 27, mu equal to 27. So this is 27. Also, the standard deviation, which is also called the standard error, is the population standard deviation divided by the square root of n. So the population standard deviation, sigma, is 4 divided by square root of 25. 4 divided by square root of 25, which is equal to 4 divided by square root of 25 is 5. That is equal to 0.8. So what we know is, since this is a normal distribution, we also have the mean and the standard deviation for this distribution. Once we have the mean and the standard deviation, we can easily find this probability that is asked here. So the question is, we have to find the probability that the mean number of hours they watch television will be greater than 25 hours. So we are actually looking for this. Let me write here. Probability that the value along the x-axis is greater than 25 hours. So that is, x bar is greater than 25 hours is how much? We need to find this. So what we need to do is, as we are working on the probability or normal distribution, you must have a labeled graph. So we are going to label this. In the middle, you have your mean. So first we are going to label that mean in the middle. Okay, mean in the middle, you can see here, your mean is 27. Mean is 27. Your standard deviation is 0.8, but we want the average to be greater than 25. So if 27 is here, 25 should be somewhere there. So this is your 25. 25. We want the probability to be greater than 25. Greater than means it is to the right. So the probability is equal to the area under the curve. So we need to find the probability which is equivalent to this area. So in order to find the area in your calculator, you'll use normal CDF. Normal CDF. Your lower limit for the area, your area begins here at 25. 25. And it extends all the way up to positive infinity, which is E99. Your mean in the middle is 27. And the standard deviation for this distribution, we have calculated here, it is 0.8. Now, if we perform this calculation using calculator, you should get 0.9938. So 0.9938 is the probability that the mean number of hours they watch television is greater than 25 hours. Sampling distribution of proportions. First, let's try to understand the fundamental concept of sampling distribution of proportion. It's a very similar concept. First, you will have a population. You can add this to your note catcher. You will have the population. And what you'll know about the population is you'll know the population proportion. You will know the population proportion, say for example, P. And if you don't know how to calculate this, the population proportion P is equal to X divided by N. Meaning of that is, when I say population proportion, if in the population, if I am looking for the proportion of the population who has master degree, as I mentioned in one of the examples in earlier class, then what we do is, out of total, out of N, how many of them have the master degree? X of them. So when you divide X by N, we'll get the value of the P. That is your proportion. That is the meaning of the proportion. That is the ratio. Okay, that is a part of the population who has master degree. We calculate using this formula. P is equal to X divided by N. X is the number of people who have master degree. N is the population size. Now, from this population, you are going to draw the samples. So you are going to draw all possible samples from here. Say, for example, S1, S2, S3, all the way up to the nth sample, Sn. So you are going to draw the samples, all possible samples of size n. Remember, the size of the sample must be fixed. So n is the size of the sample. So how many elements are there in this sample is n. N can be any number. Now, after we have these samples, you are going to calculate the proportion in each of these samples. So in this sample, how many of them have the master degree? You are going to count and divide it by n. So you will get the proportion for first sample. Let's say the proportion for the first sample is P1 hat. The proportion for the second sample is P2 hat. Proportion for third sample is P3 hat. Proportion for nth sample is Pn hat. So you are going to calculate the proportion. So now, considering this as the random variable, we construct the distribution and we say that this distribution is the sampling distribution of proportion. So here along the x-axis, you'll have the P hat and you'll draw the distribution. Suppose that is the distribution. So this distribution is the sampling distribution of the proportion. Now remember one thing, whenever we are talking about the distribution, we need the mean and the standard deviation. So mean of this distribution is here in the middle, which is written as mu sub P hat. And this mean is equal to the population proportion. The value of this mean will be equal to the population proportion P. So the first formula that you need to know is mean of the sample proportion is equal to P. You have seen this formula in the central limit theorem in previous class also. Next one is the standard deviation, or it is also called the standard error, is calculated using this formula. So standard deviation is sigma sub P hat is equal to the square root of P times Q over N, or P times Q can be written as 1 minus P. This is 1 minus P. Okay. So P times Q, because Q is 1 minus P, so this would be P divided by N. P times 1 minus P divided by N. That is the formula for the standard deviation. That is the formula for the mean. So that is the fundamental idea about the sampling distribution of proportions. Characteristic of sampling proportion P hat. So here we have two important characters that you need to know. If the sample size n is large, when I say large, maybe 100 or maybe 1000 in the sample size, and p is not close to 0 and 1, your proportion p should not be close to 0 and 1. The sampling distribution of the proportion is approximately normal. But in general, we already know from the central limit theorem that for the sampling distribution to be normal, n times p must be greater than 10, and n times q, because 1 minus p is q, n times q is greater than 10. If these two conditions are true, then we know that the sampling distribution is normal. This is something that we already know from the central limit theorem. Example, suppose 57% of all adults in the US between the age of 35 to 40 years of age exercise at least 4 days per week. So here we are checking the ratio or the proportion of the population is 35 to 40 who exercises at least 4 times per week, 4 days per week. And the general information about the population is 57% of them, they exercise at least 4 days per week. So that is your p value, the proportion of the population. So here p is equal to 0.57. So if you want to find q, q is 1 minus p, so 1 minus 0.57. So if you subtract that, you should get 0.43. Then what they are doing is, if we take a random sample of 90 adults, okay, the sample size is 90, n equal to 90. We have to find the probability that 45% of them exercise at least 4 days per week. So we have P, we have Q, we have N. So we want to find the value of N times P and N times Q first, so that we can check whether the distribution is normal. So N times P, your N is 90, times P is 0.57. If you do that, 90 times 0.57, you can do it in your calculator. I got 51.3, which is greater than 10. Also, N times Q, N times Q is 90 times your Q is here, which is 0.43. And if we multiply 90 times 0.43, 38.7, make sure you verify that. This is also greater than 10. So you can see here, n times p is greater than 10, n times q is greater than 10. And we know that when n times p is greater than 10 and n times q is greater than 10, from central limit theorem, the sampling distribution of the proportion is normal. So we can write here, by central limit theorem, the sampling distribution of proportions is normal. Meaning of that is, if along this x-axis you have your p hat, the proportion, the distribution here should be normal. So if that is a normal distribution, what we need is, we need the mean and the standard deviation. So we are going to find the mean and the standard deviation. So first, let's find the mean, which is right here in the middle. That is your mean. We write mean like that. So the mean, which is written as mu sub p hat, is equal to the population proportion. If you look at the formula, so mean will be equal to the population proportion. Population proportion is 0.57. So this is 0.57. That's your mean in the middle. Standard deviation, we write sigma sub p hat is equal to square root of pq divided by n, which is equal to the square root of p is 0.57 times q, we have here 0.43, divided by n, the population size, sample size, 90. If we perform this calculation in our calculator, we'll type the square root, and inside the square root, we'll type this. You should get, make sure you check it, you should get 0.0522. That is the standard deviation. We have the mean and the standard deviation. Now, once we have the mean and the standard deviation, we can easily answer this question here. The question is, what is the probability that more than 45% of them exercise at least 4 days per week? So we are looking for that probability. So we want to find, let's write here, we want to find the probability that more than 45%. So P hat, the proportion should be more than 45%. We write P hat here because along the x-axis we have the P hat. Okay, the proportion, what is the probability that more than 45% of them exercise at least 4 days per week? Now, first we are going to label this in the normal curve. You know that here in the middle, your mean is 0.57. This is 0.57. So your 0.45 should be somewhere here. So 0.45 should be here. 0.45 should be there. We want to find the probability that it's more than means to the right. So we want the probability that the proportion of the population is more than 45%. That is area to the right of 0.45. Now, if you want to find the area under the normal curve or the probability, we use normal CDF. So make sure you write this down. Normal CDF in your TI-84 calculator. The lower limit for the area is 0.45. Upper limit, you can see the area extends all the way to infinity, which is E99. The mean for this distribution is here, which is 0.57. And the standard deviation for this distribution, we calculated here. It is 0.0522. Now, if we perform this calculation using TI-84 calculator, you should get 0.9892. Make sure you verify that. So the probability that more than 45% of them exercise at least 4 days per week is 0.9892. So it's like 98% of the time. Okay, you'll see that they exercise at least 4 days per week. So that is the end of this example.